Hi guys, let's do this question, and I read the question. Solve the simultaneous equations, differential equations, and this is the differential equations. We are given the conditions t equals to 0, x equals to 0, and y equals to 0. And so guys, we start the question. So guys, we have the question here. So the first thing we are going to do is to write all these into Laplace transform. Convert them to Laplace transform, and when we convert, this is what we get, guys. So we say the Laplace transform of dy dt is given by that, and the Laplace transform of x is given by that. Likewise for dx dt is given by that, and for y is Laplace transform of y. And this shows that when t is equals to 0, as we have seen, the y is also supposed to be 0. So this one becomes 0. When t is 0, x also is 0. So this one becomes 0. So guys, we shall end up with something like this. Because guys, we have looked for the Laplace transform of e raised to t, which is 1 all over s minus 1. For this one is 1 all over s plus 1. Guys, we also have come and rearranged this equation so that we have like terms on the same column. So I have rearranged this and I brought it here, and this one I have brought it here. So it's like this. So just as we do in the simultaneous equation, when we want to eliminate this y, we multiply by a number in that this shall be equal. So we have to multiply by s here. So you get s Laplace transform of y plus x squared Laplace transform of x is equals to s all over s plus 1. And this is what is here, guys. Guys, for us to eliminate Laplace transform of y, s Laplace transform of y, we come and subtract. And that's why I've put negative here. So when we subtract, guys, this is now what we will get. And now, guys, we shall be dealing with this equation. And what we are generally now going to look for is Laplace is actually the value of x. The value of x. So, guys, we deal with that equation. We come and make Laplace transform of x the subject of the formula. When we make it subject of the formula, guys, we are going to get something like this. This is what we're going to get when we make Laplace transform of x subject of the formula. For us to get x alone, guys, we shall have to multiply here by inverse Laplace this side and also this side. And so therefore, guys, this is what we shall do at this point. So guys, when we do that, this now will be x alone, and while we find the Laplace transform of that, guys, then we can now multiply this to both of them. That is before we find the Laplace transform of whatever is inside the bracket. We multiply. Actually, this Laplace transform, this one is not supposed to be there, guys, because of this bracket, because this Laplace transform represent whatever is inside the bracket. So guys, ours is just to come and multiply this and that, this and that. So when we do that, guys, we are going to have something like this. We're now going to find the Laplace transform of that and that. Guys, we've given those values x1 and x2. So that x1 plus x2 will be equal now to x. So guys, that's what we are going to do. So guys, now we have this equation. Guys, before we come to do the inverse Laplace transform of which, we get our unknowns, that is a, b, and c. That is, first we disregard the inverse Laplace transform. We just divide this or make this to have these two partial fractions. And guys, we now find a, b, and c. And as I have said, that's when we do not have this inverse Laplace transform. After we have found the values, and the values are here, negative a half for A half for B, and C is a half. Now we can come and write that inverse. Now this is what we are now going to find our inverse Laplace transform, and it is actually here. So you can see these are 3 because this C we got is actually here. This is the C is here, which is a half, and the B is also a half, and the A is negative a half. So when we find the Laplace transform of that, we shall have, for the first one is negative a half e raised to negative t, plus for this is a half cos t, for this one is a half sin t. From there, guys, we come now to the second, that is x2. x2 we do the same, guys. Before we go to inverse Laplace transform, we get A, B, and C. That is disregarding the inverse Laplace transform. So that is partial fractions. So guys, after we get that, that is our values. Our x2, now we get the inverse Laplace for every term. And for every term, as we can see, x2 is equals to a half e raised to t minus a half cos t minus a half sin t. Guys, from there we just come and add x1 and x2. x1 and x2 will give us x, and this is what we now get. We have the x1 and we have the x2. When we add them, guys, we finally will get something like this. This is going to be our x. Guys, remember that, of course, we have added half cos, you get cos t, half sin t, you get sin t, and then the others we can just write them the same way they are. From there, guys, the next thing we are going to do is to find y. And guys, let me leave you find y. Use the same method. Now you can eliminate x and then find y. And so, guys, thank you for listening to me. Bye bye.